Okay, so the question is how many of the following molecules are nonpolar? And the question about polarity of molecule has something to do with the shape or geometry of the molecule. And you have to essentially draw the molecule Lewis structures on the following compound to figure out their shapes and then figure out their polarity of the molecule. The AlCl3, so aluminum, if you're looking at the aluminum here, they are in the group 3, so they have a 3 valence electron, and the chlorine surrounding by this, so they have a 3 valence electron, and the chlorine would like to form, which has formed the bond. Okay, so I'm just going to draw the structure looks like that, not showing the rest of this the lone pair electrons. So then aluminum will have the structure looks like chlorine, 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 and this is a planar triangle, and the bond electrons are being pushed equally in a symmetric way, so they are nonpolar. So this is a nonpolar. The sulfur H2S, so sulfur is in the group 6. They have a 6 valence electron, and they want hydrogen on both of them. So hydrogen has a 1 and 1 valence electron, so they want to form the bond 2. So you use 2 valence electrons, you're left with 4 electrons, which form the pairs, 2 lone pairs. So electron group wise, they are tetrahedral group. So electron group wise, they are tetrahedral. However, the molecular shape wise, they are bent structure. So in that way, this is a very similar to when people draw the water structure. They are kind of the bend, and electrons are being pulled in this way, being pulled that way. This is a polar molecule. Okay, so this is a polar. So that's the second example. It cannot be the answer. The third one, it is a PCl3. So where's the phosphorus? Phosphorus right here. So phosphorus being P, they have a 5 valence electron, and there are the 3 neighboring chlorines. So what do? They use 3 valence electron from the phosphorus to form the bonding. You have left with 2 electrons that will form the pair, so which is a lone pair electron. So if you count the lone pairs and the bond, there are 4 of them. So electron group wise, they are the tetrahedral, and the electron shape wise, this is more trigonal pyramidal. Right? So they are not on the same plane, but they are sort of the chlorine forming triangle, and then the phosphorus is sitting on top, and then there's a lone pair on top of them. So this is that's why it's called a tetrahedral structures. Anyway, this is having an electron being pulled this way, because chlorine is more electronegative, so they cannot cancel out, so they are polar molecule. So far we have only this one, chlorine is on. The last one, probably I will use a different color. The last one is SO3. So once again, sulfur has a 6 valence electron. You have a neighboring 3 oxygens. So this is a case where one way to think about it is, okay, I have equally use 2 electrons each, and oxygen wise, they have a 6 valence electrons. They can draw electron looks like the Lewis dot structure looks like that. Okay, and this will give you something a little bit funny structures. There are 3 double bonds, and with onto the central sulfur, and this is a structure. And in this case, is this central atom has sulfur has too many electrons. So what they're trying to do is, instead of sharing that, they can form the single bond. And then this, let me change that into this bond is actually completely donated to that. And then this one too, completely donated. And then you will end up having the structure S with single bond with oxygen, oxygen with 3 lone pairs now. But they develop formal charges. Okay, formal charge is 1, and this is 1. Okay, so this is the shape of this molecule, but this they can have what we call the resonance structures, so that this can be, the double bond can be up with a single bond, and they can have another resonance structures, which is up, and then double bond. So therefore, this position surrounding this, the position of 3 oxygens surrounding the sulfur is equivalent, and there, in terms of electronegativity, this is more electronegative, but they are being pulled in symmetric this way, so they are being non-polar as well. So this is a quite loaded question, and this is another non-polar. So how many do you have? 1 and 2. The answer is 2. Okay, this is a question number 2. And what is the electron geometry contain the central atom, and there's some atom in the center, and then that's sp3d2. So I write it sp3d2 hybridization. So what that means is each one of them, S will give 1 bonds, p3 means 3 bonds, d orbital there are 2 bonds because the d2. In overall, the central atom has 6 bonds onto their surrounding ligands, and so there's over a number of 6 coordination, and that's something looks like this is a center of the molecule, and then they form sort of the planar square, and there is a 1 at the top, there is a 1 at the bottom, and this is make it, there are 6 of them surrounding this, and this is called we call octahedral structures. And here's a picture that I was able to find it from the search in the internet about octahedral, and this is octahedral means there are 8 faces, and if you're looking at the pictures, there are 8 faces, you can see that. And also the one on the left is all the 6 position, if you're looking at various angle, they are all equivalent. So this is essentially a hybrid structure that they have a 6 coordination to the central. So therefore the answer is octahedral B. Okay, this is a question number 3, and which of the following molecule has sp2 hybridization? So sp2 hybridization, sp2 means there are 3 coordination. You should count not only the bonds but also the lone pairs to figure out the hybridization in the central atom. So if you're looking at HCN, and you have to know the central atom is carbon, hydrogen, nitrogen, and so so hydrogen has a 1 lone pair electron, so they must form the bonds, and the nitrogen carbon should have formed a bond, so there should be 1. But now carbon must have already used 2 lone pair 2 valence electrons, and they need to dispose 2 more valence electrons in a form of either lone pairs or forming 1 of each. So in that case, they should do this so that they don't have any lone pairs. They use all the 4 valence electrons right there by 1 single bond, 1 triple bond. Nitrogen has 5 valence electrons. They use 3 of them here, so they should retain 1 lone pair electrons. In that case, so the central atom is carbon, and their hybridization is essentially 1, 2 sigma bonding, and so therefore their hybridization is sp. So they are not sp2. And for the case of SO2, now we should think about how to draw. And once again, the sulfur is stand in the middle in the column 6. So there are 6 lone pair electrons. And you have 1, 2, 3, 4, 5, 6. And this is a similar as practice as before. And okay, why don't I put oxygen here? Doing this. This is a easy starter, and by no means this is a correct one. But by doing this, you will have S double bonds with S lone pairs, 1 lone pairs and 2 double bonds with an oxygen showing as a Lewis structures. But this one has too many. Sometimes the sulfur is salty enough, they can have these structures, and that's fine. But I would prefer to have something structure has a less burden on the central sulfur. So why don't I have 1 bonds completely given to this bonded electron, oxygen, so they form this single bond. By doing it, you're forming the negative charges and you're forming of positive charges, and you can retain this. That's one of the resonance structures they can have, and also they can have one of the resonance structures. In this case, what you can see this is there are 1, 2, 3. So 2 sigma bonds, 1 lone pairs. That makes it sp2 hybridization, and that's what it is. So this is an sp2 hybridization here, and the carbon here is sp. And let me finish up the rest of these two just in case you're wondering what kind of hybridization they have. And the oxygen here, here is, as you know, the oxygen is right here. There are 6 valence electrons, and so 6 valence electron, and chlorine will form this bonds always. So you have used 2 valence electrons, and now you have 4 to get rid of. So then overall you have this kind of structure, looks like it, and so they are 2 lone pairs, 1, 2, and 2 sigma, so they are the tetrahedral structure, and this in the central atom, and then this is what we call sp. Tetrahedral, we have a 4, sp3 hybridization. So this is one is sp3 hybridization of an oxygen in the middle. What about the xenon? Okay, xenon is here, which is one of the noble gases. So you have 8 valence electrons and in the outside. So xenon has 8 of them, and then you have 2 chlorine. So now you're going to use 2 valence electrons to form the bonding with 2 chlorines, and then how many you have left? 8 minus 2 is 6, so you will end up having something looks like that. Right? So this is a case where you are going to show the thing as xenon with triangle with up and down, chlorine, chlorine, and these are the lone pairs. And this is called bipyramidal structures, trigonal bipyramidal structures. And this has a 5 coordination, so what you can do, think about this sp3 dehybridization that makes them to have 5 coordination. So this is an sp3 dehybridization. So how many central atoms you have? The answer is number 1. There's only one, and that is happen to be SO3.